Ready to go.
Okay, so we're going to demonstrate here a project made by Josh Frederick and John Bush, two students at Spring Arbor University, who constructed a Rubens tube. Rubens tube basically takes steel pipe, and you drill a bunch of tiny little holes in the pipe, and then you pump some flammable gas into the pipe and light it. And as the propane comes out and hits the oxygen in the air, it burns all these tiny little flames. Now what we can do is set a speaker at one end of the tube, covered by a flexible membrane, and we can send some sounds through that through the tube. And what will happen, because sound's a compression wave, as the sound wave travels through the tube, areas of the propane will bunch up, and other areas of the propane will thin out, and that'll cause regions of high propane pressure, which will cause a high flame, and then regions of low propane pressure, which will cause a low flame. A low flame. So I'm going to send in a sound wave with a frequency of 300 hertz, and I'm going to turn up the volume, which will increase the amplitude or the height of the wave that's observed. And you can see we get about 2 full waves in the Rubens tube. So our frequency here is 300 hertz, or 300 sound waves a second. And if we change the frequency, let's change it to a higher frequency. Higher frequencies usually correspond with smaller wavelengths. And the Rubens tube clearly demonstrates that. You see more waves, shorter wavelengths with a higher frequency. If we change it to a